Fourier Cosine series. The Fourier Cosine series of a given function f of s is given by a0 over 2 plus sigma of n equal 1 up to infinity of a sub n cos n pi x over L on the interval 0 to L. Now, like we did before, we need to find the coefficient a sub n. So we are going to repeat the same process as we did. Now we are going to fuse this into this, and later on we'll see why the cosine series has a constant a0 over 2 attached to it. So now we drive toward this direction again. We know this is going to give us 0. So what we need to do is to multiply through this equation by cos n pi x over L. Now when we do that, we are going to get this expression or this equation. The next thing we do is to take the integral on the interval 0 to L. So taking the integral, we get this to evaluate on the right hand side. We know this is containing an arbitrary function, but we can evaluate the right hand side. So we switch our attention to that. Now, like before, we know that for m not equal to n, this is going to give us 0. So all these summations will give us 0. But for m equal n, we are going to get this expression for on the right hand side. Now, like before, we use the reduction formula again to obtain this expression for the integral on the right hand side. Now we integrate term by term to get this result. Now let's do the substitution to get this result for m not equal to 0. If m is not equal to 0, we are going to get this expression for a sub n. And when we make a sub n a subject, we're going to get 2 over L integrating from 0 to L of f of s cos n pi x over L dx. So this is going to give us the coefficients a sub m. Note that this is just a constant variable, so we can also substitute n over here to get a sub n, then cos n pi x over L. Now, what if m equals 0? If m equals 0, we are going to get this expression to evaluate to 1. So we are going to get a naught to be equal to the integral from 0 to L of f of s dx. Now, you can see clearly why we put 1 over 2 behind a naught in the expression for the cosine series. So when we make a naught the subject, we get this expression for the a naught. So a naught is equal to 2 over L evaluating from 0 to L of f of s dx. Now let us take one example. So our example is we are finding the Fourier cosine series of f of s equal x on the interval 0 to pi. So we need to find the coefficient, or we need to find the constant a0. So a0 is given by 2 over pi 0 to pi of x dx, because our f of x is now equal to x and our L is now equal to pi. So evaluating this will give us pi. Then the next thing we do is we find a sub n. So our a sub n is going to give us this expression, that is this integral. Now this is going to be evaluated using integration by parts. So using integration by parts, we get this expression for our integral. Now this is going to give us 0. And on substitution, we're going to get 0 for this. Then we are left with this to evaluate. Now if we integrate this, we get 1 over n cos nx. Then we evaluate from 0 to pi. Hence we are going to get 1 over n squared over here. So we are left with this expression. Now evaluating from 0 to pi, we get 2 over n squared pi negative 1 to the power n minus 1. So our a sub n is giving us this result. Hence the Fourier Cosine series of f is given by f of s equal pi over 2 plus sigma from n equal 1 to infinity of 2 over n squared pi into negative 1 to the power n minus 1 cos nx. We'll look at more examples in subsequent videos.